Hey guys, welcome to our final lesson in chapter 4. It's about linear programming. And part of this is just a bunch of inequalities coming together. Some of this is like evaluating. So we're not going to take brand new concepts, but we're going to take old concepts and apply it to something new. So an objective function, not functions, is an equation with two input variables, so like x and y, that is used to find a maximum or minimum. Okay, so let's start here. So we have these two objective functions here, and we have these two input values. So all you're doing is evaluating. So I'm plugging 10 in for x here and 20 in for y. And notice the p, so I'm going to plug it into that one. And here, c, I'm going to plug it into that one. So go ahead and do that. Okay, so this is nothing new. We're going to use this later to find our maximum and minimum values, but that's not going to make sense right now. So we're going to come back to this concept, but it's a really easy concept. There's nothing new here. Okay, so here's where we're going to apply this. So what you're going to do is you are going to grab the coordinate points on the corners of this polygon here. So there is a statement that says that when you have a linear programming problem, which I know we haven't really talked about that yet, but the points here are the only places that a maximum or minimum value will occur. So I'm not interested in anything in here. I'm just interested in these points. So the first thing I'm going to do is I'm going to name the points, and then I'm going to evaluate those points into this function, just like we did up here. So go ahead and name the 4 points and plug each point in for x and y into the function and see what your maximum value is and your minimum value is. Okay, so I found these 4 points and I plugged it into this function over here, and I ended up with these values. And so I'm just going to evaluate what's my biggest number and what's my smallest number. So I have a maximum. There's 2 different places I have a maximum, here and here. But I have a maximum value at 28, and I have a minimum at 58. And so these points happen. So like my minimum, it's very much stuck on that point. I have a couple options for my maximum value occurring. So we're going to apply this to the next thing that we're going to do. So graphing systems of linear inequalities, you know this. So like this is nothing new. Those are some steps to help you. And so what we're going to do is we're going to start with this, and notice it's the same function, so nothing new. And we're going to graph these linear inequalities. So I want to start off with these two because these are pretty common and they always kind of trip people up. So x is greater than or equal to 0. So think about your x values are going to be greater than or equal to 0. So I'm going to erase this, but it's going to be like all these in here, greater than or equal to 0. Your y value greater than or equal to 0. It's going to be all this in here. So when you have these two combined, we're talking about this first quadrant right here. So you're going to see that a lot. So I don't go through this process. I just know that my boundaries are going to be in that first quadrant. Okay, so go ahead and graph this. I'm going to graph that one in orange, and I'm going to graph this one in purple. So see if you can do that. Okay, so I graphed the two linear inequalities, but I haven't shaded because I wanted to talk about that. So a couple things that I am just noticing is that they meet here at this point, which is 1, 2, and they're both less than. So it's going to be like the minimum, so in here. So this part right here. So this polygon, oops, sorry, I went a little bit too much. Oh shoot. So this polygon has 4 pieces to it where they come together. Let's see, we have 1, 2, 3, and 4. And I'm going to list those 4 coordinate points over here. So we have 0, 0. We have 2, 0. We have 0, 3. And then we have that point that they came together at 1, 2. This shaded region, that's called your feasible region. And that's where things happen. Like that's the only thing or the only area that all of these scenarios can occur. And so now that I have my 4 points, I'm just going to do what I did last time and just plug those points in and find my minimum and maximum values. So I have a maximum of 20 that occurs at 2, 0, and I have a minimum of negative 36 that occurs at 0, 3. Okay, so we've gone through little baby steps of doing this, and so these are all the steps put together. So we are going to find the objective function, so we're going to have a word problem, and we're going to find the objective function. In this case, it may be 3 variables or possibly 2 variables as well. Look at the question and part of the paragraph and determine what is being maximized or minimized. So a lot of times it'll say like just find the maximum value or find the minimum value. So we're going to do that. Look at the question, determine your variables. So think word problems. So there's nothing different. Write the constraints. So the constraints are your inequalities up here. So what we're doing is like creating this over here. Graph and then find the vertices, like, and so this last part we all did. So plug in the vertices to find in your objective function, find the minimum maximum, and then make sure you're answering the question. This is imperative for any word problem. So the first thing I want you to do is I want you to read through this word problem, and I want you to figure out, let's go back up here. I want you to figure out the objective function and the inequalities. So go ahead and try that. Okay, so I just wanted to point out the objective function. It's usually pretty easy to find. So a lot of times it has to do with profit. So each batch of bread they make is $35. For each batch of muffins they make is $10 profit. And again, we're focusing on the profit. So this is going to be my objective function. Okay, so the rest of the word problem, we're going to go and create those inequalities from it. So see if you can find those. Okay, so these are my constraints, or just as we know them, inequalities. So what I want to kind of warn you about is make sure that you're being consistent on like where your B and your M variables are. So it doesn't matter which comes first, just you have to keep it consistent. So in this case, since like my B variable first, I'm going to put my B as my x-axis and my M as my y-axis. And so really, if this stresses you out or not, LI, you can call this X and Y if you want to, just whatever's easiest for you. So the first thing that's jumping out at me is that my B-intercept is 4. It's 4, 0. So I'm going to start there. My M-intercept, if I took 16 divided by 0.5, if you do that in your calculator, that's really nice too. That is going to give you 32. So 0, 32. And it's not M for slope, it's your M-intercept. So that's not on here. So let's go to the actual slope. So I don't like that. That's not really going to help me. So my slope is going to be -4 divided by 0.5. So my slope is going to be -8. So I can do something like that. So let's go ahead and go up 8 and to the left 1. Okay, so if you'll notice my green dots over here, that's just me incorporating the slope here. And I'm going to attempt to draw a line. I'm really bad about this. Sorry, that looks hideous. So you get the idea. do the same thing. I'll do it in a different color. So my B intercept is 10. So right here, and my M intercept is 20. So I can do that one. And let's see, my slope, what's confusing? My slope is 1, -1 over 0.5, which is -2. When we go down 2 over 1, down 2 over 1, oh, that comes together there. Down 2 over 1. And so it's going to, ooh, that's better. Okay, so it's going to create this, because they're both less than, in here, all this. So go ahead and figure out the 4 points that we're going to use. Okay, so I'm going to plug in like this, don't forget, this is my B value, this is my M value. So again, please keep that consistent. So we're going to plug it into this formula and get the answer. For 0, 0, obviously that's 0. 4, 0, 140, 216, that is, oops, not 260, 23. And 0, 20 is 200. So let's go ahead and see what it's asking us. So how many batches of bread and muffins should be made to maximize profit? Okay, so I don't really care about the minimum. I just care about the right there. So we're going to use this to kind of answer the question. So if I make 2 batches of bread and 16 batches of muffins, I will make a maximum profit of $230. So all this information I gained from just this problem up here. And that is it.